Hey, good morning, everybody, and all my AP Pre-Calc peeps. Okay, that's all you guys out there in the audience here. Yeah, Great Oak High School. This is Mr. Ainsworth, and we are going to get into a cool topic about polar graphing and converting from polar rectangular. Uh, there we go. So let's get started. We're going to start with polar graphing first. So I'm going to illustrate it on the left polar graph here. And then on the right, we'll get some more practice. And I have additional graphs that we can use later on when we want to do some more practice when I get back in class. Okay, and then afterwards, we're going to convert. Okay, and then the third thing you're going to do is you're going to try it on your own and get some major practice. Okay, because it's one thing doing it with me or listening to me, it's another thing doing it on your own. You got to practice. Okay, so let's get right into it. Now, rectangular form. When you graph points on the XY plane, all right, you guys already know that they're already in coordinate form, okay, x comma y. You give it an x coordinate and y coordinate, you can graph any point on the coordinate plane. Now, there is another way to do it, and it's called polar form with a polar grid. So notice that I have the polar grid superimposed over, all right, the coordinate plane. I'm talking about the XY coordinate plane here that you see on the axis. Okay, the horizontal axis is the x-axis, the vertical axis is the y-axis there. All right, and it's superimposed over the polar plane, which is a bunch of circles called concentric circles. Okay, and the first thing you have to understand is that in polar form, all you need to know is the radius of rotation, okay, the radius, and the angle of rotation theta. Okay, so r is equal to the radius. Okay, basically that's the circle you're on. And then theta here is the angle of rotation. So it's the angle of rotation. Okay, and as you guys know, if theta is positive, which means it's greater than zero, okay, that's the mathematical way if it's positive. I'll put POS just for positive. Okay, you rotate in a counterclockwise direction. Okay, CCW, all right, counterclockwise. Okay, I'm talking about this direction here. And if theta is negative, that means it's less than zero. In other words, negative. All right, you rotate in a clockwise fashion, CW. So this way, according to the clock. Okay, and that's like something that you guys already know. So nothing new there. All right, so let's get used to it. And what the weird part about this lesson is that where points, and read my note here, where points in rectangular form have only one representation, points in polar form have an infinite number of representation. Holy cow, how is it? For the same point. All right, and it's due to the fact that we have coterminal angles and a few other things. So I'm going to go slow in this lesson to try to, because I know it's a video, right? So I'm going to go slow and then just do the best you can to understand and then practice with each other and try to digest it at home. If you want to listen to this again to get a second helping, be my guest. Okay, that's what I do with videos. Okay, when I watch and learn something on my own. Okay, so let's go over some basics. All right, you're given r comma theta, radius and angle of rotation. Now the radius, oh, let me back up. Let me talk about these circles. Now these circles are called concentric circles. All right, now you might have learned this in geometry, so, and if you didn't, here we go. Okay, they're called concentric circles. And if you don't know what concentric circles are, all right, they're circles with the same center, as you can tell in the picture here. In either graph that you're looking at here, all the circles have the same origin. Okay, so circles with the same center. Concentric. Okay, concentric, circles with the same center. And when we talk about the radius, we're talking about which circle we're on. So if you're on radius 2, you're on circle with radius 2. If we have a point with radius 3, we're on the circle with radius 3, etc. Okay? All right, so let's go through a bunch of examples here illustrating the point. And all we need to know is r and theta, the radius and the angle of rotation here, we can figure this out. There's only one little thing that we got to go slow on, and that is that the radius may have a negative value as well as the angle itself. So when r and theta become negative, I'll go slow. We'll talk about the different ways you can think about it and interpret it. Okay, so I'm going to zoom in here so you can see a little bit better. Okay, let's go for it. All right, so let's start off with positive radius and positive angles. And let's write down polar form up here just one more time, just because it's new. It's r comma theta. Okay, that's polar form. So in rectangular form, it's x comma y, but in polar form, it's r comma theta. Okie dokie. All right, so let's start plotting here. So let's say our first point, called P1, is at 4 comma pi thirds. Okay, 4 comma pi thirds. So what we want to do is understand that the radius is 4 and the theta, the angle of rotation, is pi thirds. So I'm going to go out to the fourth concentric circle. Okay, and I'm just going to highlight just so you know what I'm talking about, but don't do this, just watch. Okay, so this is the fourth concentric circle. All right, it has a radius 4. Don't do what I'm doing right now. It's a video, so I'm teaching, right? Okay, so that's the fourth concentric circle. So I go out all the way to here, and then I rotate pi thirds radians. Okay, and I'm up here at 0.1. All right, but let me erase all this. All right, so let's keep this graph clean. Like I said, don't just watch and listen. Okay, on this, when it comes to a video, always watch first and then take notes afterwards, because otherwise you get lost. Okay, so you're going to go out to the fourth circle, all right, and rotate pi thirds radians, all right, which is obviously 60 degrees right here. 180 divided by 3 is 60, and you're at 0.1. That's 4 comma pi thirds. So you go out 4 units to the right and then rotate, okay, rotate. Now, this is a video and I'm just using my digital technology to my benefit or to your benefit here. So keep your notes clean here as we go through. So just go out to the fourth circle and then radiate pi thirds radians or 60 degrees. So as you guys know, this is just, ooh, sorry, get back there. Let me get back there. Okay, there we go. Just cleaning up my notes here. So this is 60 degrees. 180, pi is 180, as you guys know. Pi is 180 degrees. And when I see pi thirds, I think pi divided by 3 or 180 divided by 3 is 60 degrees. So speaking of that, actually, you have to get good at radians. So notice that my graphs are in radians mostly, except these guys down here, they're in degrees. All right, but you got to be good. You have to know both angles in radians and degrees. And the ones that are multiples of pi fourths or 40 degrees are not labeled. So guess what? We should probably label them. So grab another pen and let's label. So up here, this point right here, this is at pi fourths. Okay, I'm talking about 45 degrees. All right, half of 90 is 45. All right, pi fourths. Half of a half is a fourth. So 1/4, 2/4, 3/4. So up here, you're at 3/4 pi. So we better label the angles that are not labeled in multiples of pi fourths because they're not labeled. And I want to go over the examples of that too. I got all these graphs from Desmos, by the way. There's ways to do this in Desmos, which is really cool. So you can you can actually practice with Desmos as well, and I'll do that when I get to see you guys. So pi fourths up at the top is pi halves. In quadrant 2, all right, we have 3/4 pi. In quadrant 3, we have right here, we have 5/4 pi. All right, quadrant 4 over here to the bottom right, we have, as you guys know, 7/4 pi. So that's nothing new because we practice unit circle. So now we have all the multiples of 30 degrees, 60 degrees, and 45 degrees. And now we're ready to rock and roll. Okay, so here we go. So now we have P1, point 1, and point 1 is at, P1 is at 4 comma pi thirds. Okay, so 4 comma pi thirds. Okay, so now how do you graph a point with a negative angle? Let's go over that for next. So let's try that. So P2, our second point here, is 3 comma negative pi fourths. Negative pi fourths. Let's try that. So the radius is 3 and the angle is negative pi thirds. And when you graph a negative angle, as you guys know, it's clockwise, whereas the other one was counterclockwise. Okay, so now what we want to do is go out to the third circle. We're going to go 3 units to the right, which is right here. So take a look at, I can't make the graph any bigger than that. So you go out 3 units to the right and rotate clockwise 45 degrees. All right, and you're here at P2, which is at 3 comma negative pi fourths. Again, we did that rotation. That's a negative angle, so you rotate clockwise, you rotate pi fourths, and you're at P2. Now notice that we're also at 7 pi fourths. We're coterminal with 7 pi fourths. And this is the reason why angles in polar form have an infinite number of representations. So let me give you another representation for P2, because notice that we're coterminal with 7 pi fourths. So what we could do is rotate the other way, this way, all the way around. No. Okay, right there. Don't draw this. Just watch. Just watch, guys. Don't draw this. And at 7 pi fourths, so notice that I rotated all the way around. So this is actually equal to 3 comma 7 pi fourths. And that's why when we talk about angles, or excuse me, points in polar form, is that they don't have one representation like rectangular form. It has an infinite representations. Okay, it gets even crazier than this. So just hang on to your hats, hang on to your seats, and just try to understand. Okay, so let's keep it going here. So what happens when the radius is negative? Okay, so I'm going to just erase this stuff right through here. Like I said, I want to keep it clean. So what happens when the radius is negative? So let's graph P3 here at 4 comma negative pi 6, which is the same as 4 comma negative 30 degrees. Okay, in degrees. So how do you handle this? Okay, there are 2 ways to do it. Okay, so what you want to do, oh, you know what? You know what? Let me change that. Sorry, I want to make that radius. I was thinking about the negative radius, so let me just change this right here. -4. So what I want to do is actually -4 comma pi 6. That's what I was thinking. I'm sorry. Or -4 comma 30 degrees. So how do you graph a point where the radius is negative? So look at that. The radius is negative and the angle is positive. How do you do that? There are 2 ways to do it. Okay, so one way to do it is to go out 4 units to the left instead of to the right. Okay, so I'm going to label the x-axis -2, -4, -6, -8 to make it look like a standard x-axis right here. Because everybody knows that the points to the right of 0, the origin here, are positive, and points to the left of 0 are negative on the x-axis. So just make it look like normal right there. So what we can do, one way to do this, is to go out 4 units to the left and rotate pi 6 radians, or 30 degrees, clockwise. Okay, clockwise. So let's write down CW for clockwise. So I go out this way. I go out to the 4th circle, and 4th circle, and I rotate pi 6 radians. And so I'm right here, and that's P3. Again, this angle rotation is pi 6. So go out 4 units to the left, rotate 30 degrees, and you're at P3. That's the first way to do it. The other way to do it is pretend your radius is positive. Okay, so I'm going to just pretend that. So I'm going to graph 4 comma pi 6 first. Okay, so 4 comma pi 6. Go out to fourth circle here and irradiate. Go out fourth to the fourth circle and then rotate pi 6 radians or 30 degrees. So in this case, I'm going to the right to the fourth circle and then rotate right here, and I'm at P4. Okay, now that is 4 comma, so 4 comma pi 6. Okay, so you go out to the fourth circle, rotate your angle of rotation, pi 6, it's positive, go clockwise. So CW for, excuse me, CCW for counterclockwise. I'm sorry, I meant to say counterclockwise, go against the clock, all right, because it's positive. And then you're at P4. Now, how do you get to negative 4 pi 6? Well, if you look at the relationship between P3 and P4, if I just draw a line between the two, you notice they're opposite of one another. So P3 and P4 are opposites. So write down opposites here. Okay, sorry, I'm off my iPad here. I don't know why that didn't write that well, but they're opposites. Okay, they're 180 degrees apart. So one way people think about a negative radius is that they plot the positive radius at 4 comma pi 6 and then go in the opposite direction, 180 degrees apart, which would put you at 7 pi 6, by the way. Okay, so that's one way to do it. Okay, or one way you can interpret a negative radius. So we're getting used to this a little bit. Okay, so let's keep on practicing. So let's try and point in quadrant two. Okay, so let's do that. So let's say P5 is 6 comma 2/3 pi. So 6 comma 2/3 pi. Okay, so what you want to do is go out to the sixth circle, okay, and rotate. Or you can just find 2/3 pi and then go out to that to the sixth circle, however you want to do it. There's two ways to think about. So rotate out to the sixth circle and then, or go out to the sixth concentric circle and then rotate 2/3 pi radians, and that would put you in quadrant two here where P5 is located. Okay, so that's 6 comma, all right, 2 pi thirds. All right, everybody say 2 pi thirds. Okay. Now, if you were going to graph, let's come up with another point, negative 6 comma 2 pi thirds. All right, one easy way to get there is go in the opposite direction. And opposite of 2/3 pi, guess what, is 5/3 pi. So just go simply, look on the screen now. All right, and just go in the opposite direction. And now you're here at P6, which is negative 6 comma 2 pi thirds. Okay, so there's different ways to interpret this. I could have went out to negative 6 on the to the left of the origin and then rotate 2/3 pi radians. That's one way to do it. Or I can plot 6 comma 2/3 pi and then rotate in the other direction. I'm talking the opposite direction. So OPP for short, opposite direction, which you guys know is 180 degrees apart from geometry. Okay, so there you go. That's the basic idea. And so we learned now how to graph basically when the radius and the theta is positive, when it's negative. And we understand there's multiple ways to represent the same point. In fact, there's an infinite number of ways to represent a point in polar form. All right, let's go to the second graph here and take a look at that. So on the second polar grid, I'm talking about this one here. What are the coordinates to all these? All right, so let's talk about that. So P1 here, let's zoom in on P1, And let's write down the angles here. Let's go to red here. Let's put in pi fourths, 3 pi fourths. Okay, and just put in the angles here, 5 pi fourths. You guys should be familiar with this, and if you're not practicing. Okay, so you should be good at this right through here, and then all the way back at 0 or 2 pi radians. And work with radians here, guys, a lot, because when you go to calculus, and if you're headed there, guess what? The entire course is in radians. So just keep that in mind. So really get good at radians. Go home and practice like a madman. Okay, so let's go to pi or P1 here, point one. And point one is on the second concentric circle. So it's 2 comma something. And guess what? You're rotating pi fourths radians, so it's 2 comma pi fourths. So you just basically have to learn how to read the graph. Point two is on the third circle. All right, but it's rotated pi thirds radians, so 3 comma pi thirds. So notice it's fairly easy when you're given the point to figure out the coordinates, because again, it's r comma theta, and so you want the radius here, the radius comma angle of rotation. Okay, so this is r and this is theta. All right, how about P3? Where's P3? Well, P3 is on the second circle, so it's 2 comma something. It's rotated 7 fourths pi, so 2 comma 7 pi fourths. Now there's different ways to represent these points, so if you want to talk about that, just wait till I'm in class and we can do that. You could represent that with coterminal angles and also a negative radius, so there's different ways to do this. Just keep that in mind. P4 is on the fourth circle at 2/3 pi radians, so 4 comma 2 pi thirds here, and you guys are probably working ahead of me like you usually are. P5, that's in quadrant 4 here, and P5 is on the fourth circle, so it's 4 comma 5/3 pi. So reading the graph is a whole lot easier than graphing a point, but you got to be able to do both, and that's why I started talking about graphing first, because there are ways to represent the point in other ways with coterminal angles, as I did with point number 2 in the first graph, or with a negative radius, as I talked about. Okay, so back to this one here. Let's see, P6. Where's P6? P6 is in quadrant 3. All right, and it's on the, well, it's on the sixth circle. So 6 comma 5 pi fourths. So you have to know your angles. All right, P7, it's on the third circle. Okay, it's rotated 4/3 pi, so 3 comma 4/3 pi. So get to know how to read the graph just like you normally do when you're working with rectangular coordinates, and do the same thing with polar. Okay, I'm not going to go through all of them. All right, let's get to the second part of the lesson here. And these 2 extra graphs here, I'll use those when I'm in class with you guys. All right, part 2. Part 2 is conversion. Okay, converting. Okay, so let's recall the basic definitions of sine and cosine. Okay, so here we go. So cosine of theta is equal to x divided by r, right through here. And if you solve for x right here, we multiply both sides by r right here. And what do we get? We get x is equal to r cosine theta. Okay, so that's how you find the x coordinate. Next definition that we know of is sine theta is equal to y divided by r. And by the way, if I'm going too fast right now, that tells you need to go home and study, because you should know these. These are like basics. If you go back and look at your first lesson that we did a week ago, these are in your basic lesson here. They're like learning targets. So go home and memorize them and learn how to apply them. And if we solve for y here, we multiply both sides by r. And what do we get? We get y is equal to r sine theta. And okay, and these right here, you want to set a goal to practice well enough to memorize, and you memorize through practice. All right, let me write that down. So memorize, not through basic rote memory, okay? You memorize through, okay, practice. And something I always tell you guys, the question is who's doing it. So just keep that in mind. You know, it's you do make sure you practice the right way, learn the right way. Okay. So now we have the basic definitions of x and y. We know x is always equal to r times cosine theta, y is equal to r sine theta, and so it's actually not that difficult. Okay, so let me illustrate. So let me take a point like let me start off with P2. Okay, so point two, P2 here is at where's point two? Well, it's on the fourth circle. Okay, so just look at that. So 4 comma, and it's at 5, 6 pi. So 5, 6 pi. So there's P2. I'm going to write that down over here. So 4 comma 5, 6 pi. If you want to write that down in degrees or 150 degrees, you can do that if you want, I suppose. Okay, and notice that r is 4 and theta is 5, 6 pi. So it's always r comma theta. So when you want to find the rectangular coordinates, you just simply substitute them in. So again, r is r cosine theta. So 4 times cosine of theta, which is 5, 6 pi. And the question is what is that? And this is where all the previous work pays off. Okay, you're in quadrant 2 here, so cosine's negative here. Cosine is negative, okay? And sine is positive. Okay, so we know cosine, whatever the coordinate is, has got to be a negative number because you're in quadrant 2. All right, so what is the reference angle for this? Well, that's a previous skill too, right? So the reference angle for 5, 6 pi is directly across right here, and there's your reference angle. Okay, it's pi 6 or 30 degrees. So we have 4 times cosine, excuse me, negative 4 is because it's negative here, so I'm going to adjust it with a negative sign, pi 6. And then you got to ask yourself what that is. So I'm going to bring back your triangle here, you know, the 30, 60, 90 that is. All right, 30, 60, 90, 2, 1, rad 3. And I know that the cosine of 30 degrees, which happens to be pi 6, is equal to rad 3 over 2. Notice I don't even have the unit circle here. All right, so this right here is equal to negative 4 times rad 3 over 2. And when you simplify that, negative 4 divided by 2 is negative 2, so you get a negative 2 rad 3. And there is your x-coordinate. So that drill that we did earlier last week, where I rewrote terms of reference angle and evaluated, guess what? We're doing it right now. That's why I taught it to you guys before. Okay. Now y is equal to sine of theta. Excuse me, r sine of theta, and so the radius is 4. So we have y is equal to 4 sine of 5, 6 pi. Now the reference angle is the same, it's pi 6, and sine's positive in quadrant 2. So this is equal to 4 sine of pi 6. And if you look at the graph up here, or the triangle, excuse me, in the upper right, SOHCAHTOA, here, the sine function is equal to opposite divided by hypotenuse. So the sine of 30 degrees is 1/2. So y is equal to 4 times 1/2, which means it's equal to 2. So the y coordinate is 2. So my point, okay, P2 in rectangular form is negative 2 rad 3, comma 2. That's x comma y. That's your rectangular form. Rectangular form right here. Okay, so notice that I didn't even use the unit circle there. I used my basics. I used the 30, 60, 90, and sometimes you'll have to use the other isosceles right triangle, which is called your 45, 45, 90. which has sides 1 and 1 and root 2, to figure the other values out. And that is how the game is played. And what you guys need to do is simply try it on your own. So there's a bunch of examples here. You got to find the coordinates of these points right here one at a time and show your process. Okay? So I'll just do one more just for funsies. Okay, so P1. Okay, a P1 is on the second circle and it's rotated pi force radians. So it's 2 comma pi force. So I'll do one more. And so let's do P1 right here. Point 1. And let's see here. So P1, so x equals r cosine theta. So x is equal to 2 times the cosine of pi force. Now, if you have that memorized, it's 2 times cosine of pi force, which is rad 2 over 2, which is the same as rad 2. Okay. Y is equal to r sine theta here. Okay, again, going back to our basic definitions here. So you have to know from the past. You got to study in such a way that you know your stuff from the past. And I'm talking about the stuff in the upper left-hand corner of the screen, your definitions of sine and cosine. You have to have all these like in your mind. And if you practice correctly, they'll be in your mind. All right, and if they're not, go home and change the way you study. Okay, so here r is 2, so we have 2 times the sine of pi force. And guess what? That's equal to 2 times root 2 over 2 again. All right, and obviously if you simplify a little bit, and the 2's cancel, and you get root 2. So y is root 2 as well. So rectangular form is root 2 comma root 2. All right, so P1, again, this is rectangular form here, rectangular coordinates. All right, x comma y is in the form of root 2 comma root 2. And you just have to practice with the other points in the other quadrants. Okay, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, and it takes some time. So when you do this, obviously do it together. So instead of goofing around on your phones or iPads, actually try to work things together here, and you have time. And so take advantage of it and do it together, teach each other, learn from each other, and do the right thing. All right, don't waste your time in intervention when I'm not here. Okay, not wise. Okay, and that's how the game is played. And when I get back, I will obviously do some more work with you guys. All right, so this is Mr. Ainsworth here. Like in any video here, if you need to watch this at home to get a second helping, do that. Okay, I learn all kinds of things through videos, and I don't want to hear from anybody that it's impossible to learn from a video because I do it all the time. All right, all you have to do is just go slow or try hard, be your best, and do a good job. And I'll see you later. All right, and I'll see you when I get back. You guys take care, make yourself proud, make me proud, and I'll see you then.